Hello viewer, welcome all of you to the electric neuron. Today we are going to discuss another topic on the network theory. In the previous lectures we have already discussed the network theory, observing and delivering networks and its basic concept of network theory. So in these lectures we are going to discuss the element, active element, passive element and other element. So please stay connected with us for more video like this. And if you like the video, please share to your friend and also subscribe to this channel so that you will get immediate notification whenever I will upload a new video. So let's get started. So our discussion of this topic is first is active element and then passive element. So in the second we are going to discuss linear and nonlinear element, directional, bidirectional and time variant, time invariant with lump and distributed network. So in the element is classified into two categories. One is active, another one is passive. So in case of active, they can be divided into two groups. One is independent, another is independent. So independent also be classified into two groups. One is ideal and another one is practical. So in the ideal, there is an ideal voltage source and there is a ideal current source. Like that in the practical, there is a practical voltage source with practical current source. So like that independent, there is a dependent sources also. So they can also be dependent with the voltage source and the current source. So there are four type of dependent source, like voltage control voltage source with current control current source. Current control voltage source with current control current source and voltage control current source. And here the passive element can be divided into three categories: resistance, inductance and capacitance. So resistance is also one type of passive element, inductance also is one type of passive element and the capacitor is also one type of passive element. So here resistance can be divided into two types, that is linear resistors, another one is non-linear resistors. Like that linear inductance, non-linear inductance. So like that non-linear capacitance and linear capacitance. So now we are going to see all the description of the active element, passive element, linear element on the non-linear element. So see here, I am showing you here. So this is the active element. When element is capable of delivering energy independently, that means it is not observing any power. So it is delivering the power or delivering the currents. That's why it is an active element for a long time or approximately infinite time. For infinite time it is delivering power, so that's why it is called as a active element. Or when element is having property of internal amplifications, then the element is called the active element. So active element like voltage source and current source, they are independent in nature, and the transistor and operational amplifier, they can amplify their property, so they are dependent source. And please note that this is during the discharging capacitor or inductor can deliver energy independently for a short period of time. Remember that for a short period of time they can discharge the they can deliver the energy. Okay, so here the capacitor and inductor for a short time they can deliver energy, and capacitor and inductor is not having property of internal amplification. So that's why they are the passive element, they are not active element. Okay, so next come to the next slide. So here the passive element is when element is not capable of delivering energy. That means they are absorb the energy. That's why it is called as a passive element. So when the element is not capable of delivering energy independently, then the element is called as a passive element. So passive element example like resistors, bulb and transformer. So here in case of bulb, they can absorb the power by producing heat and light. And here in the transformer, they are not producing any power, but they transform one side to another side the power. So it is a passive element. So here transformer is just step up or a step down, that is increase or decrease the, it is not increase or decrease the power independent on Vi, V1, I1, V2, I2. So now see the one important term, that is resistance. So what are the use of resistance? Why we are using the resistance, and the definition of resistance we are going to see here. So read this statement, then we will able to understand all this concept behind the resistance. So resistance is the property of the resistors. It opposes the flow of current. So resistance opposes the flow of current by doing it convert electrical energy into heat energy. So resistance is nothing but our friction of electron. So it can be oppose the flow of electron in the conductor. So this is the one figure or network. Here the voltage source is given, and this is a closed circuit. In the closed circuit, there one resistance is connected with the series, and the current will be flowing from the positive potential of voltage to the negative potential of voltage. So here the resistance act as a resistive element. So here the electron will be opposite for some time, and this here there is heat will be produced by I square R, or this is the power is equal to I square R. So here I square R will be loss, or the W is your heat, that is I square R T. Resistance can also be written as, see here, the resistance can also be written as R is equal to rho L divided by A. So here rho is your resistivity, and L is your length. L is your length of the conductor, and A is your area of the conductor. Okay, please write all this thing so that you will able to be understand all this thing. Okay, so rho is your resistivity of the material, L is your length of the conductor, and A is the area of the conductor. And the resistance can be represented in terms of ohm. Okay, so next come to the next slide. So here I am showing you this rho is the resistive. The unit of the resistivity is ohm meter, and the conductor have the low resistivity. Please remember that conductor have the low resistivity. That's why conductor can transform current from the one point to another point, or transform electrical energy from the one point to another point, like that semiconductor and insulator. Here the resistivity is very high. Okay, so when the resistivity is zero, the material is called as a superconductor. That means there is no resistivity property, so it cannot be resist any current, so that it is called a superconductor. So example like superconductor mercury is the superconductor at 4.5 Kelvin. And please remember one formula. That formula is, see here, that is R1 is equal to R0 1 plus alpha 0 T. So the resistance will be changed depend upon the temperature. Whenever you will increase the temperature or decrease the temperature, then resistance property will be increase or decrease. So the formula, one important formula is this, that is R1 is equal to R0 1 plus alpha 0 T. So here alpha 0 is your temperature coefficient, and T is the change in temperature, and R0 is the resistance of the material at 0 degree temperature. So it is in the 0 degree temperature resistance. So for change in temperature, the resistance will be R1 is equal to R0 into 1 plus alpha 0, that is temperature coefficient, into T, change in temperature. So please remember all those things. Now come to Ohm's law. This Ohm's law is very important to your exam perspective. So please remember this Ohm's law so that you will be able to answer all these questions if the examiner asks this question. So that now see here, the Ohm's law states that at a constant temperature means the temperature remain constant. Temperature remains same, then current density, that is J, is directly proportional to the electric field intensity. So J is directly proportional to electric field intensity, is represented as E. So J is directly proportional to E. So for proportionality constant, we are denoting sigma as our proportionality constant. So sigma is equal to 1 by rho. So 1 by resistivity is your sigma. So here we are taking a conductor with a area A, and its length is L, and current will be entering from this point to this point. So the current will be flowing like this. So here Ohm's law is saying that the current density is directly proportional to the field intensity. So by applying the proportionality constant J is equal to sigma into E, so we have known the property or the formula, that is I is equal to J is equal to I divided by A. So here putting the value of J, that is I divided by A, and sigma is equal to 1 divided by rho, and the field intensity, that is E, field intensity E is equal to voltage per unit length of the conductor. So by applying this we will be able to calculate the voltage. So voltage is equal to rho into L, that is equal to I into R. Okay, so this is your Ohm's law. Let's see the another statement of the Ohm's law. So please remember this statement. This statement is very important to your exam. So Ohm's law states that at constant temperature, potential difference across the element is directly proportional to the current flowing through the element. So here the resistance and the potential difference is V. So current is flowing from the positive potential to negative potential and across the resistance. So V is directly proportional to I, and V is equal to the proportionality constant is R. So V is equal to R into I. So you can also write R as V divided by I. So it is constant at constant temperature. So there is some formula, that is J is equal to I divided by A. So unit of I is equal to ampere and A is the meter square because of the unit of area of the conductor, or E, that is field intensity. Field intensity is equal to voltage difference between the two sides of the conductor divided by length of the conductor, that is volt per meter, or sigma, that is 1 divided by resistivity, that is mho per ohm, or R is equal to rho L divided by A. Or another formula or another statement of the Ohm's law, that is Ohm's law valid when temperature and conductivity of the material constant. Whenever there is temperature and conductivity of the material constant, then the R is equal to V divided by I, this formula. Okay, so the first formula is, for Ohm's law, first formula is J is equal to sigma into E, V is equal to I into R, and I is equal to G into V. Because of I is equal to V divided by R, so we have already know the formula, R is equal to 1 by G. So put here 1 by R is equal to G. So V into G. Then we will get this formula. Like that, voltage is equal to R dq by dt. From this only, I is equal to dq by dt. So we are putting here R into dq by dt. So you will form the fourth term. Or that. So now come to the next slide. So see here, there is a voltage source Vs of EMF, and there is a current is flowing from the positive potential to negative potential with a potential drop across the resistance, that is V. Here the I is directly proportional to Vs, or Vs is your EMF. Like that, V is directly proportional to I, that is voltage drop across the resistance. Or you can also write V is equal to I into R. After extracting the proportionality constant, then we will form V is equal to I into R. So here both the current and voltage and current statement between those. Now see here, the EMF is independent on the current and the resistance magnitude, but in case of the potential difference, this potential difference across the resistance is dependent upon the current change and the resistance magnitude. If resistance is increased, then potential difference is also increased. If current is increased, then potential difference is also increased. So the potential difference mainly depend upon the current and the resistance magnitude, but the EMF, source EMF, is not depend upon the current and the resistance magnitudes. So it is clear to you. Now come to the next slide. See here, when element property and the characteristic are independent on the direction of the current, then the element is called the bidirectional element. So here the characteristic and property of an element like resistance, inductance and capacitance. So in case of resistance, there is the property of characteristic like this. This is directly proportional to or depend on the direction of the current, that why its slope is in constant. So slope is here constant, so it is a bidirectional element. So our resistance is a bidirectional element. So when element obey the Ohm's law, then the element is called the linear element. So our resistance is obey the Ohm's law, that's why the resistance is called as a linear element. Every linear element obey the bidirectional property, but the not vice versa. So please remember all the three terms which are very important to your exam. So see here, this is voltage source. Voltage source is variable in nature, so current is increased or decreased by the voltage source, and the resistance, there is a potential drop V, or the voltage can be represented like in this side. So current will flow from this side to this side. So here in the first figure the slope is in this direction, in the second figure the slope is in this direction. So resistance property cannot be changed or characteristic cannot be changed. It is directly proportional to or it is dependent on the voltage and current. Okay, so if there is increase in the current with 10% and then the voltage is increased with the 10%, so resistance is equal to V by I. So it is a constant in nature. Now see, when element property and characteristic depend on the direction of the current, then the element is called the unidirectional element. Whenever the property like diode is one element, that element characteristic depend upon the current, so it is called a unidirectional element. When element does not obey the Ohm's law, then it is called a nonlinear element. So this is the example of nonlinear and the unidirectional element. So it is voltage source with a current. This is forward bias condition. In the reverse bias condition, the diode will be act like as a open circuit, because of in the reverse direction there is no flow of current from the negative side to positive side, that's why it is open circuited. Okay, so here I is equal to I dash. Now come to see here in this three figure, you can also be observed that there in this figure this is the nonlinear, because of the negative side figure and the positive side figure is not equal, because of here the one slope is in the constant nature. Okay, and also it is unidirectional in nature, and also it is passive. Why it is passive in nature? Because of voltage and current ratio is always positive, because here positive, so voltage divided by current is equal to positive, and here negative, so negative will be cancel, both the negative will be cancel, so resistance is in the positive, so it is a passive in nature. Here also in this figure this is also passive in nature, and also it is nonlinear and bidirectional, but it is bidirectional because in the positive side and negative side, in the positive direction and negative direction the figure is same, that's why it is bidirectional. Or it is also bidirectional in nature. See here, the positive directional characteristic, negative directional characteristic are same, but it is active. Why? Because of the voltage divided by current ratio is negative, that's why it is a active element. And it also linear because of the slope is constant. If slope is constant, then that element is called the linear element. Okay, so see the fourth figure here, that is non-linear, because if slope is not constant, or it is unidirectional, or it is active, because of voltage divided by current is negative in nature. Or see the figure number 5 here, it is non-linear. So why it is a non-linear element? Because in the positive direction and negative direction the figure is or characteristic is not same, that's why it is not non-linear. Or it is unidirectional, or it is active in nature, because of the voltage divided by current ratio is negative, so that's why it is active in nature. So now if voltage divided by current ratio is positive in the both the coordinate, then the element is called as a passive element. Or when the element obey the bidirectional property or characteristic should be identical in the opposite corner but not the positive adjacent coordinate. So every linear element should obey the bidirectional property but not vice versa. Okay, now this is complete. So if you have any doubt, then please ask me on the comment section. I will clarify your doubt. Okay, so for today that's it. Thank you for watching. If you like the video, please share to your friend and also subscribe to this channel so that you will get immediate notification. Thank you for watching.